Okay, so today we're going over 5.2 is the trigonometric function of real numbers. Good
evening, Professor.
Hi.
Could you post the attendance sheet, please?
Trigonometric functions. Of real numbers. So trigonometric function of real numbers. Last time we finished 5.1. We talked about how to find the terminal point by using the t. T is the real numbers. If t is positive, we have to move from the point 1, 0 with distance, the absolute value for t, counterclockwise around the unit circle. If t is negative, we have to start from the point 1, point 0 with distance, the absolute value for t, clockwise around the unit circle. So again, so this is my unit circle. I said last time the unit circle is a circle with center is 0, 0, and the radius is 1. And I talk about how to find the terminal point by using t. So this is just review. To find the terminal point by using t is by using these steps here. Number 1, if t is positive. Number 2, if t is negative. So we're starting from the point 0, 1, and 0. We turn around clockwise or counterclockwise depending on the sign of t. With distance is the absolute value for t. This is the distance. So now we're going today to define the trigonometric function by using the terminal point. So you have to know if, for example, this is my unit circle. I start walking from this point. This is 1, 0. Walking around the unit circle like this with t, and I stop up to here, and this is my t. This point here is called the terminal point, b of x, y. This point here is my b, x, y. This b is called the terminal point. So suppose my terminal point is b of x, y, then I can define so now I can define sine of t is the same as y. So this point y is the sine function. Sine of t is equal y. Cosine of t is equal x. This my cosine. Tan of x, tan of t, I mean, is equal y over x. Now we have cosecant of t. Cosecant is the reciprocal of sine, 1 over sine of t, and this is equal 1 over y, and this y not equal 0. So 1, 2, 3, 4, 5, secant of t is equal 1 over cosine of t, and this is equal 1 over x, and x not equal 0. Number 6 is cotan of t is equal 1 over tan of t, and this is equal x over y, and y not equal 0. Any question? So by using the terminal point p of x comma y, we can find the trigonometric function. So this x is the cosine of t, and this y is the sine of t. Any question? Any question? So you have to know the terminal point to find the trigonometric functions. So the example now, yes, there is a reason for why t is y and why the yx is the cosine and y is the sine, but I'm not going to explain that. There is a reason, yes, by using the triangle, but we don't have to know it. Just you have to know if I have my terminal point, the x value, the x coordinate for my terminal point is the cosine function of t. The y coordinate, it's the sine, is the sine function of t. This just you have to know up to here. There is a reason is by using the triangle, but I'm not going to explain it. We don't need it. So now let me give you an example. The question is evaluate the trigonometric function for t equal pi over 3. So now evaluate the trigonometric function for t equal pi over 3. First of all, to do that, you have to graph the unit circle. So this is my unit circle. Now, t is equal pi over 3 positive. What does that mean? What does it mean like when I see something t equal pi over 3 positive? Here, if t is positive, starting from the point 1 and 0, move distance the absolute value for t counterclockwise around the unit circle. See number 1, if t is positive, So here t is positive pi over 3. So starting from this point, moving around this circle, distance, this distance is pi over 3. So the distance pi over 3, like start from this point, moving like this, here's the pi over 3. This point here is my terminal point, is b of x comma y. This is my t equal pi over 3. Now the question is, what is the terminal point? As we learned from the previous section from the table. What is b? From the table, from the previous section. Martin, he said 1.5 and square root of 3 over 2. Yes, this is true. So my terminal point, I get it from the table I gave it last time, is equal the 1/2 and the square root of 3 over 2. This is my terminal point. Now the trigonometric function, by using this point, this is my cosine function, cosine of t. My t is pi over 3. And this is my sine of pi over 3. So I can set here sine pi over 3 is equal square root of 3 over 2 cosine of pi over 3 is equal 1/2. The tan of pi over 3 is the sine over the cosine, is sine over cosine. And this is over this one is equal square root of 3, right? This square root of 3 over 2 divided by 1/2, and this is equal square root of 3. Sine, cosine, tan, and cosecant of pi over 3 is equal 1 over sine of pi over 3. The reciprocal for the sine is 2 over square root of 3. Cosecant, now secant of pi over 3 is the reciprocal for cosine is 2. Now cotan of pi over 3 is the reciprocal for tan is 1 over square root of 3. Any question? Do you have questions? So the same things for any terminal point, any t. If I give you t, you have to find the same steps. You have to find the terminal point, then you have to find the sine, cosine, tan, cosecant, and all of them. It's direct. Now I'm going to give you a table. So the table is like this. Okay, here's t, here terminal point, this terminal point of t, here's sine of t, cosine of t, tan of t, and cosecant of t, secant of t, and cotan. So my first point is for 0, pi over 6, pi over 4, pi over 3, and pi over 2. I need to find the terminal point. I gave it last time. Just please memorize, like remember me from last time. Okay. Now, what is the terminal point for 0 when t is 0 from last time? When the distance is 0, 1, 0. What is the terminal point for pi over 6? So open the table from last time, pi over 6. What is pi over 6, the terminal point? And 1/2. Here, what is the terminal point? You have to memorize all these things because we can't use it in the exam. What is the terminal point for pi over 3? What is the terminal point for pi? Yes. These things from the table is not from me. Just you have to memorize it. This and this and this from last time from the table. Now we're going to fill this table. Sine of t is the y value for the terminal point. What is the y value? What is the y value from the terminal point? Is 0, exactly. The y value here, 1 over 2. The y value, square 2 over 2. Y value, 3 over 2. The y value is 1. So this is the y value. You can set here the y. Now for the cosine is the x value. Here you can set x like this. What is the x value? 1. Here, x 3 over 2. Here is the square root of 2 over 2. Here is 1/2. Here is 0. Now for the tan is the sine over cosine. What is the sine over cosine for each column, for each value? The sine is y over x. Y, this y over x. Y over x. 0 over 1, 0. 1/2 over 3, square root of 3 over 2 is
Square root of 3.
square root of 1 over square root of 3. This value over this one. Now here over this one is 1. This one over this one is square root of 3, 1 over 0. What is 1 over 0?
Undefined.
Undefined. We don't have value here. Now here, cosecant is 1 over sine. What is 1 over sine? 1 over 0. What is it? What is 1 over 0? 1 over y? What is 1 over 0?
Undefined.
Undefined. Here, the reciprocal for 1/2, what is it?
2.
2. Here, what is the value? 2 over
1.
this one. 2 over the square root of 2. We do the reciprocal. Here we have 2 over square root of 3. Here 1 over the reciprocal for 1 is 1. Now the secant is 1 over cosine. Again, the reciprocal for cosine 1, 2 over square root of 3. Here 1 over x, 2 over square root of 2, 2, and here undefined again, because we can't, 1 over 0 is not undefined. For the last one, cotan is 1 over tan, or x over y, x over y. So x over y, 1 over 0 is undefined. But I told that we cannot have a radical as a denominator. What do you mean? Let me do this first. So x, then I will go over your question. Is x over y, so this one over this one, they give me square root of 3. This one over this one is 1. This one over this one is 1 over the square root of 3. And the last one is 0 over 1 is 0. What's your question, Angel? We cannot. No, it's fine. We can use the radical in the denominator. It's fine. But if you want to change the radical for the denominator, just you multiply by the congruent. Like you can multiply both sides here for the square root of 2. Or you can multiply the both sides by the square root of 2. Or here the both sides of the third root of 2. It's completely work. It's fine. You can like put in the denominator. But the denominator must be not equal 0. This is the important things. Okay? The denominator not equal 0. Okay? It's completely fine if the denominator not equal 0. It can be rational, irrational, whatever. Okay. Any question for this table? So the important things now, as we see here, this value does not have a value. Yes, we have memorized this all the time. As we see here in this table, this here does not have value, the cosecant. And here does not have a value, for the tan, and here it does not have a value, and here does not have a value. This means there is a domain for the function. So what is the domain? So now I can define the domain as this. So the domain of trigonometric function Okay, so suppose my function, so the function here, and here the domain. So here is the function and here is the domain. So the function is the sine function and cosine function for the tan function and secant for now the cotan and for cosecant. For the sine and cosine function, the domain is always R. I can plug any real number inside the function, the sine and cosine. Any real number, I can plug it inside the function sine and cosine. If we're going back to here, I don't see any issues in the sine and the cosine. All the boxes are filled. So the domain for the sine and cosine is always R, all real numbers. For the tan and the secant, here is the tan and here is the secant. They have issue at pi over 2. And this means all the numbers I can plug inside the function except pi over 2, and any element of the, like, I can plug any real numbers except this is minus pi over 2 plus and pi. Any element of this form I can't plug inside the function. And here is natural number. Here is mean the natural numbers. The natural numbers are 1, 2, 3, 4, any natural number. So the domain is R except this element, pi over 2 and plus 2 pi. I mean here n is and also 0. So natural numbers and 0. So I can start from 0 and all natural numbers. Or I can set any integer too, because also if I plug the minus also work. So I can set n belong to the natural integer numbers, because also if I plug the minus numbers are work. I mean like dot dot dot, minus 3, minus 2, minus 1, 0, 1, 2, all this are work. For the cotan and cosecant, cotan has a problem here and cosecant have the same things. So for 0, the function has issues, cannot plug 0. So this means the domain is R, all real numbers, except n by. And here n again is belong to the z. Can be 0 because the 0 belong to the z, so 0 times pi is 0. Could be like pi, 2 pi, 3 pi, 4 pi. All these numbers, I cannot plug it inside the cotan. They give me undefined. Make sense? Clear? So now we know what's the domain. Now I know which element I can plug inside the function and which element I cannot plug. What is the z is the integer numbers. The z here means the integer numbers. It is minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. This is integer numbers. The positive natural numbers and the 0 and the negative natural numbers. This is it. Okay. So after I know the domain and the range, I mean just only the domain for the trigonometric function, now I'm going to the sign of the trigonometric function. The sign. What is the sign for the function? Is positive or negative? So here I can set the sign of trigonometric functions. So here is my unit circle. Here is my unit circle. If I walk around this unit circle with t equal like t is between 0 and pi over 2, and I stop up to here until here, and this is my terminal point. This is my terminal point P. So I mean all the function, the sine, the cosine, the tan, and the reciprocal for all these functions are positive. So here I can set all. All are positive. All positive. And if I keep walking around this circle, I can change the color by a different color. So here I can set all. I mean for all the functions are positive. I mean for sine, cosine, tan, and the reciprocal. So here is my t. If I walk around this circle and I walk like this and I stop up to here, and this is my terminal point P. The only function is positive in this one is sine. The sine function is positive for the second quadrant. The only function is positive is the sine function. Again, if I walk from this point and I stop up to here, the only function is positive here is the tan. The tan function here is only positive, and the other are negative. So walking around like this, stop here. And now, if I walk around this circle and I stop here, my terminal point in this side, this quadrant, the cosine function is the only one is positive. Cosine. So how can I memorize these things? All student take calculus.
All student cheats.
No, cheese is not good. Okay, so I can say all from A, student S, take T, C calculus. All student take calculus. Yes, all student take cash, if you like cash. So in this function, in this quadrant, all the trigonometric are positive. The second one is sine, third one is tan, fourth one is cosine only. Any question? Okay. Now, how to evaluate the trigonometric function? How to evaluate these things? This is the important thing. Now, to evaluate, there is a step. Here is the steps. To evaluate trigonometric function, we're going to use this step. To find the value of the trigonometric function for any real number t, first things we have to find the reference number. Second one, we have to find the sign. Third step, we have to find the value. So reference, the reference means like t bar. From last lecture, t bar. Find the sign by using this, all sine, tan, cosine. Find the value. So example, find each of the following. Number one, find the cosine of 2 pi over 3. First step, when you see something like that, you have to graph here the unit circle. Here is the unit circle. Here is my unit circle. Now, I have to walk around this circle with distance equal the absolute value for this. In which quadrant this value? 2 pi over 3. In which quadrant? 1, 2, 3, 4.
Two.
Number 2, yes. I'm going to explain why 2 for students who like a little bit confused. This point is 0. This point is, let me use different color. This point here is 0. This point is pi over 2. Pi over 2. This point is pi. This point is 3 pi over 2. And again, you go back to 2 pi. Pi over 2, if I want to make that, like starting from pi, if I want to make the numerator, the denominator over 3, I have to multiply the numerator and denominator by 3, because this is pi over 1 actually. So this is equal 3 pi over 3. Pi over 1 or pi is actually equal 3 pi over 3. And pi over 2 is equal 1.5 pi over 3. How I know pi over 2 is 1.5 over 3 pi. I'm going to do it here. Pi over 2 over 1. Multiply this by 3, multiply this by 3. I get 3 pi over 2 over 3. 3 over 2 is 1/2. Pi over 3. So the denominator is 3, the denominator is 3, and here I can make it like 6 pi over 3. So the denominator is 3. Now I have 2 pi over 3 is between 1/2, 1.5, and 3. So 2 pi over 3 is like around here. So this means I have to walk around this circle, starting from this point, walk on like this, like that, and stop here. This is my terminal point. This is B. This point is my terminal point, B of x, comma y. Okay. Now let's do the step. Find the reference. What is the reference? The reference is the shortest distance between my terminal point, between here and the x-axis. So this is my t-bar. What is the t-bar from last time? What is the distance between the x-axis and the terminal point? What is the t-bar here?
Pi over 3.
Pi over 3. That's true. Because this point is 3 pi over 3, 3 pi over 3. And from here to here is like around 2 pi over 3. So subtract by 2 pi over 3. They give me pi over 3. This is my reference number. Number 1, find the reference. This is my reference. So t bar, or the reference, the distance, is pi over 3. We talk about distance. We don't talk about any angle. Just we talk about distance. The distance from this point, the terminal point, and the x-axis, t bar, is 3 pi over 3, subtracting the blue one. The blue one is 2 pi over 3. The blue one is my t. This is my t equal 3 pi over 2. I mean 2 pi over 3. 2 pi over 3. It's not good. 2 pi over 3. So now t reference is pi over 3. Find the sine. Because the terminal point is in the second quadrant. What is the sign for cosine? Is positive or negative? Which function is positive for the second quadrant? What the function is positive in the second quadrant? It's the sine. The sine function is positive in the second quadrant, and anything else is negative. So the cosine in the second quadrant has a negative sign. So the cosine has negative sign. This is first step, this second step. Now third step, evaluate. So I said like this: cosine of 2 pi over 3 is equal negative cosine of the reference number pi over 3. is equal minus, what is the cosine of pi over 3 from the table? Cosine pi over 3, here, this pi over 3. The cosine is 1/2. So the answer minus 1/2. Any question? Any question? Is it clear? The negatives come from second step. The pi over 3 come from the first step, t bar. The answer from the table before. Cosine pi over 3 from this table. Here is pi over 3. The cosine is 1/2. Here, the cosine is 1/2 for pi over 3. I found it by using the terminal point from previous section. Another example. The question is, number 2, find sine 19 pi over 4. Who will give me the step? Find the reference numbers. But before starting to find the reference numbers, 19 pi over 4 is like big and large number, is like greater than 19 pi over 4 is like greater than 2 pi. And when the number is greater than 2 pi, because 2 pi actually, if I want to make it over 4, is 8 pi over 4. This number is greater than 8 pi over 4. 19 pi over 4 is larger than 8 pi over 4. So I have to simplify this number. How can I simplify? Exactly, we can subtract until no more, or I can say 19 pi over 4 is equal 8 pi over 4. Why 8 pi over 4? Because this is 2 pi plus 8 pi over 4. 8 plus 8 is 16. The remaining is still a 3. So plus 3 pi over 4. Or I can subtract, like Angel he said. So I can subtract or I can add. So 19 pi over 4 is equal 8 pi over 4 plus 8 pi over 4 plus 3 pi over 4. 8 plus 8, 16, plus 3 is 19. So this is pi over 4. And this is equal actually 2 pi plus 2 pi plus 3 pi over 4. So now we simplify this number. We simplify this number. Two pi means we turn around the unit circle one time, and the 2 pi again, we have to turn around the unit circle again 1 pi. Then I have to turn around the unit circle 3 pi over 4. Let me graph to show you exactly what this is mean. Here is my unit circle. (19 pi over 4) means I start from this point, walking around this unit circle like this. This is 2 pi. I finish the first one. Then I move again 2 pi like this. I stop again. I finish the 2 pi, this 2 pi. Now I have to walk 3 pi over 4 around the unit circle like this. 3 pi over 4 is stop here. Here, this point. So I finish it. So actually, I stop in the second quadrant. Why 3 pi over 4 is in the second one? Because the same step, like I said before. This point is pi, and this is equal 4 pi over power 4. This point is pi over 2, and this is actually equal 2 pi over 4. So 3 pi over 4 is between 2 pi over 4 and 4 pi over 4. So the point will be here. And we stop here. Like walking around the unit circle one time, then again one time, then go back to this point. So this is my terminal point, B of x comma y. My question is, what is the reference number? First step, t bar. What is the t bar? Is the distance between here and the closest x-axis and here. A distance, t bar. Pi over 4, exactly. This is true. How I know? Subtract 4 pi over 4 from the blue one. So 4 pi over 4 minus this one, 3 pi over 4. And they give me pi over 4. The distance here is pi over 4. T is pi over 4. Number 2. Find the sine. What is the sine for the sine function for the second quadrant? The sine for sine function in the second quadrant is, for the second quadrant, positive. The sign is positive here. Look, all sine, tan, cosine. All students take calculus. So the sign is positive for the second quadrant. So the sign for the sine function is positive. Now the third step, I have to set sine of these things, 19 over 4, 19 pi over 4 equal positive, this positive, this one, positive sine of the reference number. What's the reference number? Is pi over 4. So here pi over 4. Going back to the table, sine pi over 4 is this things. Square root of 2 over 2. Square root of 2 over 2. And we have positive, so positive square root of 2 over 2. Any question? Anyone has a question? Is it clear? So again, when you see the number here is greater than 2 pi, the 2 pi here is 8 pi over 4. When it's greater than the 2 pi of these things, so you have to change it. You have to like subtract 2 pi, or you have to like write it like this form is equal 8 pi over 4 plus 8 pi over 4. You keep adding 2 pi until you arrive at in the last one. The last one will be like this, the things I'm going to use it to find the reference number. So 3 pi over 4, I use it to find the reference number, and also I continue solving this question. The even and odd function. So even, odd function for the trigonometric function. This I'm going to use it for important things, even odd property. So you have to know the only even function is the sine function and the tan function. And the odd function is the cosine function only. So the even function and the odd function. The even function is the sine, and the reciprocal for the sine is cosecant. So if sine of minus t is equal minus times the sine of t, because the sine function is no, it's not even function. Here you have to change it. This is odd here. This is the odd function. This is the even function. Now is good. So the odd function, sine of minus t equal minus of sine of t, and the same things for the reciprocal for sine is cosecant 1 over sine. For the tan also is an odd function, tan of minus t equal minus t of minus times tan of t, the same things for the reciprocal. The only one is even function is the cosine. Cosine of minus t is equal cosine of t. Same things for the reciprocal, secant. From before, I said even function means f of x equal minus even function from chapter 1, f of x equal minus f of x. So my f of x is cosine, positive. Look, everything is positive. Minus f of x, not minus. The minus is inside, equal f of minus x. So the minus is inside the cosine. So this is mean even. The odd function I said before, f of minus x equal minus f of x. This means the function is odd. My function is sine. Sine of minus t equal minus sine of t. So this is the odd function here from first chapter in the book, and this is even. So the only function is even is the cosine function and the reciprocal. Example for that. Any question? What do you mean look different? Supposed to look different? Justin. Is the secant supposed to? Oh, okay. Thank you. Thanks. Yes. There's something wrong. Thank you. So now it's good. Yes. Thank you, Justin. So secant of minus t equal cosine of t. Secant of minus t equals secant of t. Now it's good. Now here minus sine cosecant tan cotangent. Yes. Now, so let me give you example how we can use these things. So the example, find by using the even and odd. Evaluate. The question is sine of minus pi over 6. Number 2, cosine of minus 4 pi over 4. So the sine function is an odd function. So sine of minus t is the same as minus sine of t. So the first one I'm going to do it. Sine of minus t equal minus sine of t is equal minus sine of pi over 6. And equal minus, what is sine pi over 6 from the table? Pi over 6, 1/2. Pi over 6, the sine is 1/2. No, Angel is 1/2. Okay? Cosine minus pi over 4. The cosine is even or odd? This is for you. Is even. So the cosine of the minus is the same like the cosine without the minus. So this is equal cosine of the pi over 4 without the minus. What is the cosine pi over 4? Square root of 2 over 2. Or 1 over square root of 2. The best things is to apply it for negative knowing. If you're applying for positive and you change it to negative, you will not get the answer. This things is the most important for negative. That's why they use it. If you have positive, don't use the positive. Don't change it to negative. Just use this step. This step, first, second, third, and you find the answer. This is for negative only. If you have negative, it's better to use make it positive, because if after you found it positive, you can use the step here. 1, 2, 3. If it's positive, don't change it to negative. You will not get the answer. Be so hard. Now, the fundamental identity. So the fundamental identity fundamental identities. So first identity is the reciprocal identity. Then the second one is the Pythagorean identity. And the Pythagorean identity, I'm going to write it down with a different color. Yes. Okay. So this is the fundamental identities. The reciprocal identity is like cosecant, cotan, and this all functions. Like cosecant of t is equal 1 over sine of t. Number 2, secant. This is called the reciprocal identity. Secant is 1 over cosine of t. Cotan of t is equal 1 over 10 of t, and this is equal also cosine of t over sine. The 10, 3, 4. Tan of t is equal sine of t over cosine of t. 1, 2, 3, 4. This is the reciprocal. Now, the Pythagorean identity. Pythagorean identity, first one, you have to know the sine square. Number 1, sine square of t plus cosine square of t always equal 1. Number 2, you have to know tan square of t plus 1 equal secant square of t. Number 3, you have to memorize all of these. You don't have to use, you can't, you have to memorize it in the exam. You can't like use it. Cotan of square of t is equal cosecant square of t. Any question? So this is called the Pythagorean. Sine square plus cosine equal 1, tan square plus 1 equals secant, 1 plus cotan equal cosecant square. This is the reciprocal. The last example in this section, by using these identities, is like this. So if the cosine of the function t is given like 3/5. This is cosine, given like as 3/5. And this t belong to the second to the fourth quadrant. Belong to quadrant number 4, like this, in the fourth quadrant. The question is find the values for all trigonometric function. So to do these things, I prefer to graph the unit circle. Is the easiest way how to solve this question. So this is my unit circle, and here t is belong to the quadrant number 4. This is mean I have to start walking from here around the unit circle like this, and I stop up to here. This is my t. You can't use the calculator. You can't use the calculator for questions like this. So the question is, they give me the cosine and they told me t is in the fourth quadrant. This is my t. This is my b. Now, if the cosine they given, the cosine of t in the fourth quadrant is positive, 3/5. How can I find the sine? How can I find the sine? How can I find the tan, cosecant, and all of them? You can use these things, but I'm going to use the identity. What about if I use the first identity here, the Pythagorean identity? Sine square plus cosine square equal 1. The cosine is given from the question. I need to find the sine. This is true angle. You can use the arc, but I'm going to use the Pythagorean identity. So you have to use the sine square plus cosine square equal 1. So sine square of t plus cosine square of t equal 1. The cosine is given 3/5. This one is given 3/5. So sine square of t equal 3/5 square equal 1. Now I can find the sine. So the sine square of t equal 1 minus 3/5 square. 1 minus 3/5, what is 3/5? Is equal 1 minus 9/25. Yes. 1 minus 9/25 is 25 minus 25, because the 1 is 25/25, minus 9/25 is equal 16/25. So the sine square is 16/25. Take the square root of for both sides. I get sine of t equal positive, negative. Square root of this is 4/5. Which one I have to use? The positive or the negative for the sine? Because sine of t is positive or negative. Which one I have to use? In the fourth quadrant, the cosine is positive, and anything else is negative. So the sign in the fourth quadrant supposed to be positive or negative? Negative, because in the fourth quadrant the cosine is positive and the sign is negative. So sine of t should be negative 4/5. So the cosine of t is given 4/5. So now I have two things. The sine of t is negative 4/5. The cosine from the question is 3/5. Now I can find the term. T is sine over cosine of t. This over this, minus 4/5 divided by 3/5, giving negative 4/3. Cosecant of t is 1/sine minus 5/4. Secant of t is 1/cosine 5/3. Cotan of t is 1/10 minus 3/4. Any question? Any question? Anyone has a question? Everything is fine? Okay, if there is no question, let's go to the 5.3 new section. This section is direct, easy, is 5.3. We're going to learn how to graph trigonometric graphs. So now we're going to graph the functions. First things we have to know, the sine and cosine function are periodic function. Okay? The sine and cosine function are periodic function. That means their values are repeated after 2 pi. After 2 pi, their value are repeated. So the function sine and cosine have period 2 pi. So the period for the sine and cosine function is 2 pi here. the function sine and cosine have period 2 pi. This is mean every 2 pi the function repeating their values. So I can set here now sine of t plus 2 pi is the same as sine of t. And also I can set cosine of t plus 2 pi is the same as cosine of t. Now I'm going to graph the sine and cosine function by using the plotting point. Then we're going to use the transformation. So here, graphing for sine t and cosine t by this. So I'm going to make a table. This table has t here. I have sine of t. No, first of all, t terminal point the sine of t and the cosine of t. So if t is starting from 0, walk around the unit circle distance pi over 2. For the second one from pi over 2, walk around the unit circle around pi. Third one from pi, distance from pi to 3 pi over 2. And the third one is 3 pi over 2. Walk around the unit circle for 2 pi. So for the terminal point, if I start from t equals 0, the point will be like around 0, 1, 0, right? At t equals 0 is 1, 0, the terminal point. At t equal pi over 2, the terminal point will be 0, 1. So I'm working from 1.0 to 0.1. Same things here. If t is pi over 2, the terminal point is 0.1, goes to that. If t is pi, terminal point here is negative 1, 0. Same things here. From negative 1, 0 goes to this terminal point. Terminal point here is 0, minus 1. Again, 0, negative 1 goes to 2 pi is 1 and 0. So the sign, like I said before, is only the y value. For the sign is only the y value. So this is mean goes from 0 to 1 only. Here from 1 to 0. Here from 0 to minus 1. And here from minus 1 to 0. How I get negative 1 and 0? This is the terminal point. Negative 1 and 0 here is the terminal point. I mean, like, if I walk around the unit circle like this, and I stop at this point is -1 and 0, and t here is pi. Here's my unit circle. I start at this point, walk around like t equal 2 pi, stop here. This is my terminal point. This point is -1 and 0. T equal pi here. -1 and 0. Okay. That's why here the pi is -1 and 0. 3 pi over 2 is 0 and -1. Now for cosine is the x-axis. X coordinate is 0 from 1 to 0. From 0 to -1. From -1 to 0. From 0 to 1. Now it's easy to graph. So the graph now like this. If this is my unit circle, and here is the graph of the function. So this is my unit circle. Here is 0, pi over 2, pi, 3 pi over 2, 2 pi. From this point to this point, here is 0, pi over 2, pi over 3, 2 pi. From here to here, and here is 1. Here's -1. Okay, so from here to here, the graph will be something like this. From this point to this point, the graph will be something like this. Y from the table, go back to the table. Y from pi over 2 to pi, here, pi over 2 to pi, the sine function is from 1 to 0. The value from 1 to 0, this is the sine function. Sine t function. From here to here, this is from pi to 3 pi over 2. From pi to 3 pi over 2, the sine function from 0 to the -1. So here is 0, and here is -1. The value goes like this. The last one is from 3 pi over 2 to 2 pi. 3 pi over 2 to the 2 pi. The function goes from -1 to the 0. Here's -1, the 0 to 0, like this. And I know the function is periodic, so it will be like this. Continue like this. And the same things here. Okay, any question? So right now you know the general idea how to graph the sine function. Same things for the cosine. The same things for the cosine. Cosine function, the same things. From 0 to the pi over 2 goes from 1 to the 0. The amplitude, I'm going to talk about the amplitude next time. The amplitude is going to be changed, but not in this graph. So the graph for this one, just we know how to graph the sine function from the unit circle. So we're going to stop up to here today. From the unit circle, I can graph this function. Next time, I'm going to continue for how to graph the cosine function. Okay, have a good night, everyone. Any question before we finish this class? Anyone has a question?
Thank you, Professor. Good night.
Okay, have a good night, everyone. And see you next week. Don't forget, we have tomorrow exam.